today's video will show you how to deal with heteroskedasticity in data regressions. So heteroskedasticity is a very important hypothesis that is needed to check when running linear regression. Alongside of normality and non-autocorrelation of error term, we should also check the heteroskedasticity of error term. So when error terms are heteroskedastic, there are statistical techniques that are used in order to fix this issue. So for the purpose of the video, we have data containing information on GDP, the gross fixed capital formation, general government final consumption, as well as GDP growth and gross fixed capital formation and general government investment. So we'll run a linear regression and show you how to correct heteroskedasticity. So, and it's the first time you are watching one of my videos, do not hesitate to subscribe and activate the notification bell in order not to lose the next publication. And a like or a thumbs up will be a pleasure to know that efforts we are making are helping you improve your statistical model for social sciences level. First of all, start by running a linear regression using the command regress. Dependent variable be local current local currency. The independent variable will be the gross fixed capital formation in percentage of GDP. We have general government expenditure, and finally we have private sector gross fixed capital formation. Then click on OK, and we can see that the results of our linear regression are already available, and we have only a gross fixed capital formation that is significant because of the p-value of the coefficient is less than 5%. We can try to test for our heteroskedasticity by first of all predicting our residual terms. So first of all, we'll generate a variable that we call residuals, and we'll use it to test the heteroskedasticity of our linear regression model. So we'll use the command predict the variable called residual and comma with the reserved word receipt to say to STATA that the variable that is going to be predict is the residual of our linear regression. Then click on OK, and you can see that a new variable called residual has been generated. We'll use it to test for heteroskedasticity of our error term. So we'll use the command het test followed by and then click on OK, and you can see that the p-value of our heteroskedasticity test is 0.0054, that which is less than 5%, entailing the rejection of the null hypothesis of homoskedasticity. So our error term are just heteroskedastic. So how to correct the skedastic? One option is to use a variance robust option of Hecker and White in order to have a model that have error term that are almost skedastic. So we'll just rerun our model comma and use the reserved word robust, and then we'll estimate a new model that property of robust variance of Hecker White. So then we click on OK, and you can see that the result of our variable appear with different in significance of coefficient with not high difference in coefficient value, but this model that has been estimated by robust option have error terms that are not heteroskedastic but rather homoskedastic. So that's it for this tutorial, and we hope it have helped you understand how to deal with heteroskedasticity in linear regression. And if you have not done so, do subscribe and activate the notification bell in order not to lose the next video.